Combine the product and quotient rules with polynomials. So in this video we're going to be talking about taking derivatives of functions that have both products and quotients in them. So this is going to get a little bit messy, but let's dive in. So for y equals the quantity 3x plus 2 times the quantity 3x minus 4 all over negative x squared minus 2x plus 4, we're being asked to find the derivative at x equals 1. Well, if we look at this particular function, we can see that there is a product in the numerator, so we're going to have to use the product rule. And then there is a fraction, so we are going to have to use the quotient rule as well. Alright, so we can see here that there are actually three distinct functions. We have 3x plus 2, which we will call f of x. We have 3x minus 4, which we can call g of x. And then we have negative x squared minus 2x plus 4, which we'll call h of x. Now, because we have a product rule inside of a quotient rule, we're probably going to have to use these three functions as well as their derivatives at some point. So we might as well just go through, put our training wheels on, and figure out what these derivatives are all going to be. So, we know we have f of x, and that's going to equal 3x plus 2. We can find the derivative of x, which will just be 3. Moving on to g of x, we have g of x, which is equal to 3x minus 4. And then the derivative of g of x will just be 3. And then finally we have h of x, which is negative x squared minus 2x plus 4. And the derivative of that is going to be negative 2x minus 2. Alright, so now that we have all the different components and we have all their different derivatives, let's start to break this down. Well, we can see here that y is a rational function. So we can start out with y being equal to the top over the bottom. So when we want to take the derivative, we are going to be using the quotient rule here. So that means that y prime is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom. And that's all going to be over the bottom squared. Alright, so we now know that we have to use the quotient rule and we have the derivative. But first we need to define what the top is, what the bottom is, and then find their derivatives. Well, when we refer to the top, we're referring to the top of our fraction. So therefore, we can see that our top is going to be f of x times g of x. So if we want to take the derivative of the top, here's where our product rule comes into play. So it's the product rule embedded in a quotient rule. And we know the product rule is f prime times g plus f times g prime. So we have the top, we have the derivative of the top. Next up is the bottom. And we can see here that the bottom is just going to be our h of x. So therefore, the derivative of the bottom, or bottom primed, is just going to be h prime of x, which we've already figured out up here. Oh, sorry, we already figured out up here. That was a little bit too quick. Alright, so now from here, we can just plug in the derivative of the top, and the derivative of the bottom, and continue working our way through. So let's see, y prime is going to be, the derivative of the top is f prime of x times g of x plus f of x times g prime of x. And then it's times the bottom, and we know the bottom is h of x minus the top, which is f of x times g of x, and that's times the derivative of the bottom, which is h prime of x. And that's all going to be over the bottom, which is h of x squared. All right, so we could go ahead and we could substitute in all of our different expressions for f prime g, g prime f, h prime. But since we're trying to find the derivative at 1, we can just find the actual numerical values and substitute those in. So let's go ahead and let's find the numerical values for all of our pieces. So f of 1 is going to be 5, because 3 times 1 is 3 plus 2 is 5. F prime of 1, well, that's always going to be 3 no matter what the input is. G of 1 is going to be negative 1. G prime of 1 will always be 3. Now let's see, h of 1 is going to be 1, and h prime of 1 is going to be negative 4. So now we can plug in the numerical values and then just simplify to find the derivative of y at x equals 1. So therefore, y prime of 1 is going to be, let's see, we said f prime is going to be 3 times g, which is negative 1, plus f of 1, which is 5, times f prime, which is 3, and then times h, which we said was 1, minus f of x, which we said was 5, times g of x, which we said was negative 1, and then times h prime, which is negative 4. And that's all going to be over h, which is 1 squared. All right, so now all we need to do is simplify the numerator and denominator. And if we simplify the numerator, we could plug all that into the calculator, and we're going to get the value of negative 8. And then the denominator is 1 squared, so that's going to be 1, which means our derivative of y at x equals 1 is going to be negative 8. Whew, so wasn't that a doozy? And yes, when the product rule is inside the quotient rule, it is very tedious. But if you can break it apart piece by piece by piece like we did here, it's going to go a long way and make things seem much easier. Not shorter, just easier. So let's take a look at one more. So this time we're going to let k of x equals f of x times g of x, and that's all over h of x. And we're told if f of x is negative 4x minus 2, and g of x is 4x plus 1, and h of x is negative 3x squared minus 2x plus 4, what is k prime? So this example is asking for the derivative in general, not at the derivative of a specific point. So here we are going to have to actually plug in our expressions and do a bunch of distributing and simplification to get our answer. All right, so let's start off where we did before. So here, the way that our function is defined, we already know that f of x and g of x are in the numerator, and h of x is in the denominator. So we can go through, identify all these functions, find their derivatives, and start just like last time. So let's see. F of x, we are told, is going to be negative 4x minus 2. We can take the derivative of that, and we can get the derivative to be negative 4. Next up is g of x, and the problem tells us that g of x is 4x plus 1. And then we can take the derivative, giving us a derivative of 4. And then we need h of x, which we can see is negative 3x squared minus 2x plus 4. And then we can take the derivative, h prime, is going to be negative 6x minus 2. All right, so let's see. We're going to start off with our function k of x, and we know that's going to be, it is a quotient, so just like before, we're going to have top over bottom, which means we're going to eventually need to define those terms. But if we do take the derivative, we can apply the quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom, and that is all over the bottom squared. So just like before, we need to identify our top function, which we're already told what that is. That is f of x times g of x. And then we can take the derivative. So here's where the product rule comes into play. Again, it's buried inside the quotient rule, but good news, we know the product rule. Or if we don't, we can always look at our notes. And we know the product rule is f prime times g plus f times g prime. And then we have the bottom, which we know is h of x. And then we can take the derivative of the bottom, which is just going to be h prime. Whoa, that's not an h, that's an n. H prime of x. All right, now it's time to substitute in. So k prime of x is going to be the top is f prime of x times g of x plus f of x times g prime of x. And that's all times the bottom, which is h of x, minus the top, which is f of x times g of x, and then times the derivative of the bottom, which is h prime of x. And that is all going to be over the bottom, which is h of x squared. All right, get ready, because now here's where we get to do the fun algebra stuff. Plugging everything in. So let's see. This is going to give us, we know that f prime is negative 4 times g, which is 4x plus 1, plus f, negative 4x plus 2, times g prime, which is 4, and that is times h, which is negative 3x squared minus 2x plus 4. And, I'm not going to fit this in. All right, so let's see, where can we, I'm going to take this work right here, and let's just shrink that down, and then we can bring this up and move it up here so we have a little bit more room to work with. All right, so continuing on this, we're going to have f of x, which is negative 4x minus 2, times our g of x, which is 4x plus 1, times the derivative of h, which we can see is negative 6x minus 2, and then this is all over negative 3x squared minus 2x plus 4 squared. Whoo! This is going to be fun. All right, let's hit it. Well, we can distribute the negative 4 in, and we can distribute the positive 4 in, and then let's see, we can FOIL this guy. So this is going to give us negative 16x minus 4 plus negative 16x plus 8. And that is still times negative 3x squared minus 2x plus 4 minus, now let's see, that's going to give us negative 16x squared minus 4x minus 8x minus 2. And that's all times negative 6x minus 2. And then that is all over the denominator, which is negative 3x squared minus 2x plus 4 squared. Oh gosh, okay, moving along here. Let's see, we can continue simplifying the numerator. And let's see, negative 16 minus 16, that's going to give us negative 32x. Negative 4 plus 8 will give us plus 4. That's going to be times negative 3x squared minus 2x plus 4. And then minus negative 16x squared minus 12x minus 2 times negative 6x minus 2. And that is all over negative 3x squared minus 2x plus 4 squared. All right, now because I ran out of room and this is really taking a long time, we're just going to jump straight to the answer. So simplification done behind the scenes. And that's going to leave us with negative 4x squared plus 140x plus 52 all over the quantity negative 3x squared minus 2x plus 4 quantity squared. Alright folks, and there is our derivative, and we are done with learning how to combine the product and quotient rules with polynomials.